Welcome to Examrace. This is the quantum mechanics and we are here for Pauli Exclusion Principle. So we here start with the two particle system. For one particle system there is a one function that is psi. For two particles obviously there is a two functions that is psi, but it depends upon the two positions r1 and r2, or you can simply take psi1 psi2 or psi that depends upon the means one particle's position or coordinate is r1 and another particle coordinate is r2, and also on time t. And also the Schrodinger equation, we know that I h cut d psi over dt must be equals to h of psi, where h is equals to minus h cut square upon 2m for a first particle, del 1 square minus h cut square upon 2m2 for second particle. This is del 2 square plus v of, this is for r1, r2 and time t. So this is what we got. And from here, if I statistically interpret the function, then my function will be like, if I want to find the normalization of that function, that my function will be like psi of r1, r2 for time t, and this whole square dr1, d3r1, d3r2, and which must be equals to 1. So this is what the normalized function we can find. Now, but if I want to find the function as of time t, so it's psi r1 r2 time t, which is equals to psi for r1 r2, and for time it is e to the power minus I e by h cut into t. This is the way we can find the function respect to the time. But if I want to find the Schrodinger equation in the time independent, then it will be different from, because this is the Schrodinger equation, or this is the Hamiltonian equation for time dependent, because it is depending on the time. So my time dependent function is psi1 r1 r2 time, that we already know, which is going to psi1 r1 r2 into e to the power minus I e t by h cut. Simple. But when we talk about this time independent Schrodinger equation, then it is quite different, and it is minus h cut square over 2m. For first particle it's m1, so it's del 1 square minus h cut square over 2m2. For second particle is del 2 square plus v of psi, sorry, it's not pi, it must be psi. And also here you can also say psi, so this is psi plus v of psi must be equals to E of psi, where we can say what is E. E is the total energy of system. Simple. Now we talk about the bosons and fermions, and for this, suppose we have one particle and its state is psi of a for r. Second particle, this is first particle, this is second particle, with a state psi of v as a function of r. So my combined state that I remember is r1 r2. This is my combined or single state for two particles, so I write it as combined state, okay, or combined function or state, whatever. Now which means that r1 r2 means combined state must be like psi of r1 into psi b for r2. So this is what the combined state, and here we know what is psi 1 and what is psi b. Psi is psi a and psi b is for the state for particle 1 and particle 2 for the different position R1 and R2. Now the question arises that this is for the classical case only. Okay, so if we see the quantum mechanically, these are particles are indistinguishable. For example, if we see the particle classically, then we can distinguish the particle just by mark them. But this is not possible in case of the quantum mechanics. So particles are indistinguishable. So if particles are indistinguishable, then there are the two ways to write the wave function, and that two ways is that psi plus and minus for R1 R2 must be equals to psi A R1 psi B R2 plus and minus psi it's okay, we have to take A all common, psi A R2 into psi B R1. Okay, so this is the case for classical, and this is the case for quantum mechanical. Okay, now what does it mean that if two particles are indistinguishable, then we separate them by using symmetric or antisymmetric, that is we use the sign plus and minus. We already studied about the symmetric and antisymmetric. Now but here we will see the two kind of identical particles, and what happened to their sign, what happened to their spin. We see about this. Means these two particles we will talk about as the bosons and fermions. So we define the particle function or state as for R1 R2, which is going to be A times psi A R1 psi B R2 plus minus psi B R1 psi A R2, like this. Here what is the plus sign denotation? Plus sign denotation is for the, since two particles are indistinguishable, so plus sign is for the bosons. Let me mark that. Okay, not hard and fast rule, but we see that. Okay, negative sign is for the fermions. Okay, so this is what the actually what are bosons? If we talk about the bosons, bosons are basically bosons are photons. Bosons example is photons and mesons. Okay, mesons. These are the example of boson. And if we talk about the fermions, fermions have the example proton and electrons. These are the example of fermions. So if I define better way what a kind of boson is, so if I give the example, but how can I say boson is something? Boson is something that all in case of boson, all particles with integer spin. Okay, integer spin means it is either +1, -1, +2, -3, some kind of integer is there. When we talk about the fermions, and fermion example is electron, and you have heard the electron has plus half spin, minus half spin. So from this what we conclude that fermions are the particles with half integer spin. Okay, integer spin. It can be +3/2, -3/2 also. It can be 1/2 plus or -1/2.